Hello, this is Team Lighting Control System for our final group project, and this is the system that we have created, and this is Luis, Anthony, Ryan, and I'm Andrew, and we created a system of sensors as well as an OLED to output their states. So let's go to slide 2.
So this is our finite state machine that we have for our project. On the left is the one that's being used for the entirety of the project. So it's including our two sensors and then our dimming. And then it's also on the right side, we have the FSM diagram that we created for the OLED screens. So for the OLED screens, in order to have multiple displays and have different information shown on each display, we created a state for each of them, and then with a GPIO input, switch from screen to screen in order to update them or scroll through them. And on our for our FSM diagram for our actual project, we have we start with our infrared sensor detecting any motion, and then once that is actually true and there is motion detected, our photocell sensor will start enabling current to pass through. So then our LED is going to be turned on, but the way it's going to be turned on is with with a variable resistance depending on how much actual lux is coming in. And then all that can also be manually controlled with a GPIO input through a FSM cycle of a dim states. So we're going to have 5 different dim states that go from dim to brighter and then back to dim. And then that will cycle back to the start.
So here for this image, we created sort of a schematic for our system. And as you can see at the top, we have the Nucleo, the Nucleo K303 board. That's just an example. We were sort of playing with different boards. But so as you can see, there are different pins. So you have, like, for example, GPIO ins, GPIO outs. And we'll go more into detail later as we explain our individual parts and the components of the system. But there we have an IR sensor, we have a light ambient sensor, and then we have different buttons for dimming. And there's an OLED display that's going to be displaying the different states that we have for the different parts.
And then for our planning of this project, we had our initial proposal where we made our initial FSM diagram, how we were going to build everything. And we got a inventory of all the parts that we'd have to order, all the sensors and everything. And then we made a more official schematic and FSM diagram with our individual assignments, what each of us were going to do. So then we consolidated our assignments and we combined everything for our end results.
So one of the main issues that we ran into for troubleshooting had to do with a potentiometer dimmer code. So originally, instead of dimming codes dimming buttons, we were going to use a potentiometer. And we were going to use an ADC input pin. It was going to be reading the output from the potentiometer that was connected to a voltage source. And it was working initially, but after a couple tries, it was the first run actually, we weren't detecting an output signal to the LED from the board. So what the board was supposed to do was supposed to detect an ADC input from the potentiometer, depending on what the resistance was, of course. And that was supposed to be converted into a signal to the LED, and it was supposed to affect the brightness. So we resolved this issue. We had to improvise a little bit. We replaced the potentiometer with sort of increase and decrease buttons, and those buttons sort of move through the states of brightness, and we adjusted our code accordingly. We ended up having 6 states of dimming total.
And then we also ran into some issues with setting up the OLED screens. Originally, I wanted to have 4 OLED screens so that way we could have one displaying the LED status, one displaying the dimmer status, one displaying the photoresistor status, and then one displaying the motion sensor status. But then once I realized the drivers were kind of set up for OLED screens of just one display at a time, I found out it was too much troubleshooting to try and figure out that problem. So I just decided to implement a little scrolling function with the push of a GPIO input, and that just changes the screen. And I used system states for that, and that's how I was able to show our multiple outputs on one screen. So for the OLED display, I decided to go with the SSD 1306 drivers that were shown in one of the extra lab handouts. I used a 128 by 64 pixel OLED display, and it was pretty simple to set up. You just provided some power, a ground pin to it, and then the actual signal, or like the connectivity pins, are through the SCL and SDA pin, and you just set that up in the STM Cube application in the connectivity settings, and then that way you're able to interact with the drivers, choose your font, choose the font size, and then place exactly where you want to place your text. As you can see right now, we have the title, and then we're going to have various screens to scroll through with our names, and the states of the different sensors and LED screen, LED status.
For the execution of my IR sensor in this whole light motion sensor is I use this ADC as previously touched on in the troubleshooting that collected the data from the sensor and communicated with the STM and then touched on the LED light or the OLED. The hardware I used wasn't too intricate. I used the sensor, the STM, depending on my individual demo, or the final one, I used the L432KC. In the final one, we used an OLED and just the breadboard resistors and jumpers, the typical things you'd see on this. How it functions is the sensor itself has an emitter and a receiver. The light emitter emits the light, and then once it detects motion, it will receive less light than normal, put into a value that I put under IR, which sets off the threshold and turns on the LED or triggers the OLED. The purpose of this sensor in our project is to sense motion and use that as a component for our automatic lights.
Now for the ambient light sensor, I created a ADC input with the light sensor that, depending on the certain ambient light levels, it will input a higher level of voltage with higher ambient light. And so with a double nested if-then statement, I made it so as long as there is less than a certain amount, it will have light dimming with the lowest resistive circuit output. And then as the voltage goes up, it goes to a low dimming and then a high dimming level with those three diodes at the end, making it so that they don't interact with each other's voltage levels.
And so for the user-controlled button LED dimmer, that was my part. As I explained before, it was originally supposed to be a potentiometer, but we replaced it with buttons, and we adjusted the code accordingly. So now each of the buttons is receiving 3 volts from the 3-volt terminal, and when the buttons are pressed, each of them are connected to one GPIO input to the board, one each respectively. And depending on when there's an input, there's going to be one of 6 GPIO outputs for the 6 dimming states. So the STM controller reads the input from a button, and depending on the input, it's going to trigger a GPIO output, and the buttons, they trigger backwards or forwards changes in the dimming states respectively. Based on what I said earlier again, the potentiometer sort of became, the button sort of became what the potentiometer was supposed to be. And ultimately, the purpose is to provide sort of a demonstration of the dimming function and sort of provide manual control over the dimming rather than a sensor controlled aspect.
All right, and here's our demo for our project. So right now our screen is displaying just the title, which is EEE174L, the lab final, and I can cycle through the different states with the click of this button. So right now it's displaying our names. I skipped through Andrew's, but it's okay. So this first one, it's going to be detecting the status of this LED light. So this is the motion sensor that Ryan is going to be talking about now.
Yes, so the motion sensor is basically a modified IR sensor where if you put your finger or hand above it, it'll receive different amounts of light, which will trigger it to turn on the LED and communicate with the OLED.
And we can see that happening right there.
And then we have the ambient light sensor that senses the light level of the room, and if there is more light in the room, it will dim the light more. And the light level in the room is a little bit low right now, so we're gonna have to use a flashlight.
Give me a second. So in order for the photo resistor to actually work, the motion sensor has to be covered because someone actually has to be in the room if you want your light to be dim. Otherwise, the light wouldn't even be on. So I put a piece of paper so I don't have to be holding my hand over it. And now I'm gonna, like Andrew was saying, this room is a little dark. So right now the LED light is on its highest setting. And once I shine this light on, right now it's detecting low light on the photo. And as soon as I start to shine the light on, you can see it changes to medium. And then if there's too much light, it turns all the way off. So this would be its high setting, and you can see the LED light changing based on how much light there is. Ideally, this would be sunlight, because if you have sunlight, you don't need your lights to be on, so you can save a little bit of energy. And then this is the dimmer function.
Yes, so as you can see, once he starts pressing his the button, the states of the dimmer starts to change. You can see it sort of increasing in brightness slowly. Those are the 6 states of brightness.
And then it's off.
Okay.
And then there's just one more screen. Thank you. Okay. So this is our code for our final project. Here at the beginning, I included some fonts and drivers for the OLED screens. Here are just some configurations I had previously. And then here are my 2 state machines. As I mentioned, I have one for the different screens and one for the different dimming states. Here are just the screen state machines. As you can see, it's depending on the input and then changing if it's having a high input or not. Displaying our names. This is displaying the LED status, off or on, based on this GPIO pin input. Same with the motion sensor, same with the photo. This one uses the lux in order to measure how much light is coming in order to display a message. And then down here, just the different dimming states. So in order to have dimming, we have to turn off all the other ones and turn on one specific resistor. So that's what we have here. And then these are just our while loops for our switch states. And this is the code for Andrew's photoresistor, which is pretty similar to the dimming one. You set a bunch of resistors and reset a bunch of other resistors in order to have a correct output. And then this is all based on an if statement of the lux. And that's it.